In partnership with Brighton Java, we could not be more excited to announce our next speaker. Taking up the early afternoon slot, one of the most recognisable names in the Java world, Trisha G. Trisha has expertise in Java high-performance systems, is passionate about enabling developer productivity, and even dabbles with open source development. Leader of the Sevilla Java User Group, Java champion, and a developer advocate for JetBrains, she updated her Java 8 talk just for us today.
Hello, I'm Trisha G. I'm a developer advocate for JetBrains. I generally talk about Java and usually IntelliJ IDEA, usually those two things together. What I'm going to talk about today is the sort of TLDR of everything that's happened in the Java world since Java 8. There's a lot that's happened since Java 8, so we're going to try and cover this fairly quickly. So let's move right on. Why am I saying from Java 8 onwards? There's been a lot of change in the Java world lately. Why am I setting my standard as from Java 8? Well, let's look at the numbers. The JetBrains Developer Ecosystem Survey, where we published the results last year, we had about 83% of developers using Java 8, and the rest of the developers are sort of scattered around the other versions. The next in line is 22% of people using Java 11. The New Relic survey, the results were published earlier on this year, shows something sort of similar. 85% of developers using Java 8, another good chunk of people using Java 11, and then everyone else using other versions. I did a super scientific poll over Twitter at the weekend and got 100 results. And again, we see a bunch of people using Java 8, a chunk of people using Java 11, and then a bit of a smattering around the other versions. Now, this might look like a weird distribution because why would you have a whole chunk of people on 8, a large chunk of people on 11, no one on 9 and 10, and then some other versions attract some users and others don't? In order to understand this, we need to understand a little bit about how releases, updates, licensing, and support has changed since Java 8. In fact, since Java 9, we've been releasing a new version of Java every 6 months. Not me personally, but the people who are releasing the language are releasing it every 6 months. There's a new version every 6 months in March and in September. The most recent version was this March, so that's last month, and that was Java 14. We actually have two different types of releases now. We have these 6 monthly releases and we have long-term support releases. The reason being that, generally speaking, the vendors who support the JDK don't want to be supporting each release that comes out every 6 months for 3 years or so. That's going to get kind of insane. So they've nominated various releases, one every 3 years, to be a long-term support release. Java 8 was a long-term support release, Java 11 is a long-term support release, and presumably Java 17 will be a long-term support release too. Now, it's important to understand that this is largely the story from Oracle. Now, most of us have probably been using an Oracle JDK since forever. So let's understand that from Oracle, support for the long-term support releases is paid for, but the 6 monthly releases are free. So now we have two options when we're looking at a version of Java. We can either use the free Oracle OpenJDK, which is replaced every 6 months, and we can use that completely for free, which means that at the moment we should be on Java 14 because the most recent one came out last month, and that's Java 14. Or we can be using an LTS version, a long-term support version, but depending on which vendor you get your JDK from, you may have to pay to use it in production, particularly with Oracle. In which case, if you're using a long-term support version, you will be on Java 11, as this is the most recent long-term support version. But Oracle is not the only game in town. There are a bunch of different vendors who release versions of the JDK. If you go to jdk.dev, you can actually see a huge list of them. And particularly, you might want to look at Adopt OpenJDK. There are free releases of OpenJDK, and they also have support and updates for a long period of time. So, why perhaps would we want to bother upgrading? The new licensing that I just talked about in terms of things like long-term support and paid for releases came in Java 11 and the new monthly updates since Java 9. So maybe we might want to sit quite comfortably back on Java 8. Well, let's look at things like the new language features in Java 11, the most recent long-term support release. Firstly, JShell. This is actually not a language feature per se. Let's take a quick look at it. This is the REPL. Now, Java's got a REPL. If you've been working in other languages, you might be used to working with a REPL. For Java developers, probably not so much. So here I've got a terminal open. So JShell is just another application that's in the bin directory of your version of Java. I happen to be using Java 14 here because I updated to the most recent version, but JShell came in Java 9, so you have it from any version of Java from Java 9 onwards, which means it's in Java 11. JShell allows you to do a bunch of stuff like, let's see, what can we do? It's got tab completion, so we can do system.out.println. We can say, hello. It's got nice bracket matching. And guess what? I don't need to put a semicolon on there. I can do things like declare variables. So I can do anonymous ones like, I don't know, let's say that it creates me a variable called $2, or I can say var number equals. And so there you go. And then you can do a bunch of stuff. It supports forward references. It supports creating objects. There's a whole bunch of stuff. It gets quite complex. It's quite a good place to try out using new versions of Java. So if you want to play with things like the use of var, I've jumped ahead slightly and shown you the use of var. If you want to play with some of the new features that I talk about in this presentation, you might want to play with them inside JShell. It's quite a nice area to just start playing with stuff. All right, that's JShell. In Java 11, we've got var that was introduced in Java 10. var just allows us to get rid of a bunch of the boilerplate around declaring variables. Let's have a look at an example. So the point about var is to reduce the boilerplate that you have in your code. So I can actually replace explicit types with var, which is quite nice. There are caveats, like there are places where it's not really a good place to use it, but we can use it in places like this, where perhaps, what have we got here? We've got a byte array output stream called output stream. So it seems like a good idea to just replace that with var. Just don't really need to use the type of it. And my IDE will obviously still tell me what the type of the object is. So I don't necessarily have to say the type absolutely everywhere. It's just a little bit redundant. So yeah, there's a bunch of places where we could do that. Let's say we do need to be a little bit careful. If I do that, that's fine. This is still a list of strings, but if I do this, this becomes a list of objects because you have to declare the type somewhere. Here, the list of creates a list of strings. Here, it creates objects because we haven't told it which type it is. So we can't just replace everything with var. And it's not about dynamic typing. It's about reducing boilerplate where the type is known. So it's a nice feature. We can reduce types where it's just noise, but it's not something one would automatically apply to your whole code base. One of my favorite features which is available inside Java 11 is convenience factory methods for collections. We actually just saw them in the previous example. Let me show you what it is. It allows us to create a list using list.of. That's kind of nice. It's not really a huge improvement over arrays.aslist in terms of the number of characters required, but actually it is kind of interesting because arrays.aslist creates a list whose size can't change, but actually you can change the values inside it, so it's not immutable, but list.of is an immutable list. Let me show you some other examples. For example, in order to create an actual immutable list inside Java, you should do arrays.aslist, wrap it inside collections.unmodifiable list, and then that gives you an unmodifiable list. But in Java 11, you can just turn that into list.of. That's nice. What's more interesting is that sets were always a little bit difficult to create because you create a list, then you wrap it inside a hash set, and then if you need it to be unmodifiable, you need to wrap that inside an unmodifiable set. That is much, much easier in Java 11. You just say set.of. It's much easier. And then what we can do is kind of interesting around maps, because maps, if you want to create a map, if you want to initialize it with a bunch of values to begin with, that gets a little bit unwieldy. But in Java 11, you can say, oh, that's kind of wrapped in a funny way. Where's my wrapping? Ooh, lovely. Right, so you can say map.of, map.entry. Okay, and then you basically have map of entries where you create an entry with the key value pair. This is how you do it if you have more than 10 entries to go into your map. Okay, and obviously if you really want, you can static import your map.entry, so you reduce some of the boilerplate there. It's a little bit easier if you, let's undo this. Let's put it back to how it was. If you have fewer than 10 values, let's see if IntelliJ does this for me. Map.of. Then this becomes a little bit easier. It just, it's literally key value, key value, key value, key value. Okay, and you could just see it puts it into there. So we can just say map.of. It's not quite as pretty as maybe the Groovy syntax for creating maps, but it's significantly better than what we had in Java before. So that's our convenience factory methods for collections. Also in Java 11, you can collect to unmodifiable collections. So the factory methods all create unmodifiable collections. In Java 8, we could collect to a list. Now you can collect to an unmodifiable list. So you can return from your method an unmodifiable list and know that no one is going to be tinkering with the data that maybe you might be using. Another new thing in Java 11 is there's new methods on the Streams API. The Streams API is extremely helpful in Java 8, but there are a few things which were arguably missing from it. One of which is the ability to perhaps take while or drop while. So take while is you're going to iterate over this stream. Iterate's not a great word, but you're going to look at this stream for every entry up until some condition is met. And drop while is the same but the reverse. So ignore everything up until some condition is met, and it's quite a useful way of managing very large or infinite streams. Java 11 also introduced predicate.not. This might sound kind of stupid. It's literally just a method where you actually have to add the words not instead of using an exclamation mark. But let me show you why it can be kind of interesting. So in Java 8, for example, if you're looking for something like, if you want to filter out all the strings which are not empty, obviously you put a not around it. But some people kind of prefer to use method references sometimes, and you can't use this in a way which will allow you to use a method reference unless you extract this out into its own method. Whereas in Java 11, you could say, instead, let's import this. This is probably in the... Oh, what happened here? Oh, I've got two. Huh. Okay, so instead you can use predicate.not, and you can use a static import, and then you can use a method reference if that's the thing you want to do. So it's really just a stylistic thing. You can use it if this is your preferred way of reading code or writing code. Otherwise, you can carry on using the exclamation mark if you want to. So predicate.not in Java 11 allows you to use a slightly different style if you want to. There are a bunch of new methods available on optional in Java 11. Optional was a new thing that came in Java 8. It allowed us to say that a method might return a value or it might not. For example, find something, okay, then it returns an optional and it might be empty. This was kind of valuable, although it did have some limitations. It was supposed to allow us to program in a functional style, but it didn't always allow us to get away with using lambdas and programming in a more functional style. Sometimes you still had to wrap things in an if and else. The new methods on optional allow us to do way more functional style things with an optional. It just becomes a lot prettier to work with. The methods are things like is empty, or else throw, if present or else, or and stream. So that allows us to use things inside a lambda expression way more often than we could before. I'm not going to go through all of those because I think either you're using optional or you're not. So if you are using it, you probably already run into some of these limitations. I urge you to have a look at the optional API in Java 11 because there's some interesting stuff there. Java 11 also has a built-in HTTP client. This is particularly useful for things like testing. But yeah, you might find instead of having to use an external library or external tool, using the built-in HTTP client makes your life a lot easier. Now we're going to move away from some of the sort of syntax level features that maybe developers are interested in and look at some of the bigger picture stuff that are more interesting for the community as a whole. Multi-release jar files are available in Java 11. That allows things like library developers to use newer versions of Java if they want, but package it to using a single jar file in a way that you as a user can get the jar file at the right version of Java that works for you. So this is very helpful for language for library developers. I wrote about this a little bit. It came in Java 9. It was available in Java 11, obviously. I wrote a bit about this on in this blog post. If you're interested in creating multi-release jar files, this process might have changed a little bit over the last couple of years, but still, fundamentally, that's where you'll find out a bit more about this idea. Having mentioned Java 9 a little tiny bit, in Java 9 we had this idea of Jigsaw. You may have heard of it, you may not, which we're now encouraged to call the Java module system. This is where it was a huge project that was the main drive of Java 9. This is where the language developers actually created a module system for us to create modular Java, but they also modularized Java itself. So the huge amount of everything that was the JVM, the JDK, not the JVM, the JDK, all the language stuff that's part of the JDK, they managed to modularize it into lots of smaller pieces, which is kind of interesting to us as developers. But if we're not using the module system, we might say, well, what was the big fuss about? But it actually allows things like this 6-monthly release cadence. It allows a bunch of other interesting features, like, for example, JLink. JLink is the ability to create a small deployable of your application with just the bits of Java that you need. So just the modules that you use, only the tiny bits of Java that you need. So instead of having to deploy your application and a JRE or JDK of your choice, which has got huge amounts of everything, you can just pick and choose the bits you want and create a much smaller deployable. This allows you to do things like create very small Docker images, deploy very small things into the cloud. So it might potentially even save you money in terms of size and use. So this can be very useful. Now, we talked about Java 11 because Java 11 is the current long-term support release. Now I want to talk about the language features which are available in Java 14, as Java 14 is the most current version of Java. So if you're updating every 6 months or updating to each new release as it comes along, this is what you'll have if you have or are going to update to Java 14. The first thing is switch expressions are available in Java. So switch expressions, they went through this process of preview features. I don't really have time to talk about what preview features are at the moment, but the short version is the 6-monthly release cadence allows us to do things like put in a not test, but a preview version of a feature for developers to play with and give feedback on until it becomes like a standard version in Java itself. So switch expressions went through this process of having several preview versions in earlier versions of Java. In Java 14, switch expressions is a standard, fully usable feature in Java 14. Switch expressions are quite nice. Let's take a look. Now, anyone who's programmed in Java probably knows that a switch statement is not the prettiest thing that you can see. So here we have a sort of classic switch statement. And switch statements, if you want to assign something to a variable inside a switch statement, you have to declare your variable and you have to put all these things and the break and all this nasty stuff. In Java 14, you can just use a switch expression, which uses nice pretty lambda expressions, nice pretty lambdas, allows you to put more than one case here, allows you to set a default value, and allows you to assign all of that to a single variable. So now if you want to, this can be final, whereas previously it couldn't be final. It had to be a variable. This is a blog post where you can read a bit about switch expressions. It does say switch expressions and IntelliJ IDEA because a lot of what we write about is inside IntelliJ IDEA, but it does give you an overview of what switch expressions are, how you can use them, and why they're quite good. The switch expressions have evolved a little bit. They were introduced as a preview feature in Java 12. The Java 14 version is slightly different, but it's really a tiny thing, so that you won't see much difference between the Java 12 version and the Java 14 version. Speaking of preview features, in Java 14, we have a preview feature version of text blocks. Text blocks is probably going to be standard in Java 15, so there's probably not going to be much that changes here because it's already been through a couple of iterations of the preview feature thing. Let's take a quick look at what text blocks are. In Java, generally, if you have long strings, particularly if they've got things like HTML or other languages inside there, it can get a bit ugly as you have to escape a whole bunch of stuff. Text blocks allow us to get rid of that. So let's automatically replace this with a text block. So instead, you start your text block with 3 quotes, and you finish it with 3 quotes. And then you don't need to escape anything in here. Everything that you print in here is just a plain string, so I don't have to escape any of these things. I can even, if I'm using IntelliJ, I can actually say, let's say this is JavaScript, and then I even get, so I get code completion inside here, which is quite nice. So it works quite nicely for things like JavaScript, embedded HTML, maybe even SQL, so you can just replace it with a text block. So text blocks are a preview feature in Java 14, so you shouldn't really use them in production. They probably won't change much before they make it probably as a standard feature in Java 15 in September. Records, I'm really excited about records. Records is a preview feature, a new preview feature in Java 14. This will probably go through a bunch of iterations before it becomes standard. Records are like Kotlin data classes, or a bunch of other languages have got the idea of small classes which literally just have a header. You don't have to have getters and setters and toString and hashcode and equals. You can actually just have just the record declaration. There we go. So our record just looks like this. We can literally just say we have a name, an ID and a name. We don't need getters, setters, toString, hashcode, equals. All of that is kind of done under the covers. We can override those things if we want to, but we don't have to. Records also have this idea, they have a slightly new version of a constructor, so a compact constructor. So I don't need to say, I don't need to declare everything which comes in because that's already been set up here. So if I wanted to do something, I could call something like validate my fields with the ID and the name. So that's what I would use that for. I don't need to say that this is going to take an ID and a name. It's going to be there, part of the record. So that's records. You'll note that all of these features have got a link to the IntelliJ IDEA blog because my colleague Malagupta, she does a great job of summarizing all the new features in Java in the IntelliJ IDEA blog. So I don't need to talk too much about them here because it's already been done. There's also a bunch of videos here for each of the new features, so that's really nice. The other interesting new preview feature in Java 14 is pattern matching for instance of. Oh, I've missed out the word of. But yes, pattern matching for instance of. Let's take a look at what that looks like. So for example, if you do an instance of in Java, generally you also then have to do a cast and turn it into another type of variable. And it becomes a little bit clumsy, which is kind of dumb really, because here you've already done a check. You know it is an employee. Why do I have to cast it to an employee as well? In Java 14, you can simply replace it with a pattern variable up here. And then you can just use that. You don't need to cast it. Okay, so it's a fairly small feature, but it leads to bigger features. This idea of pattern matching will incrementally, they'll be able to change some of the syntax of Java, so some of the clumsy boilerplate goes away, and some more interesting things can happen in Java, particularly around things like switch expressions and some other places. So this is just quite nice, one of those nice little features that can make life a little bit easier. Now, I've just given you, the developer, a whole bunch of features that may or may not be interesting to you as a developer to work with Java. But when you're trying to sell this to your team lead, your architect, or the business, they're really not going to care about whether you can use the new methods on optional or not, or whether you can use records, because maybe they're like, why didn't you just use getters and setters? Who really cares? So why would we want to update to a new version of Java? Generally speaking, every new version of Java is better performance. Generally speaking, when you're using the latest version of Java, your application, without any changes whatsoever, will perform better. You will generally see things like maybe faster load times, maybe smaller garbage collection pauses, maybe lower latency operations. Generally speaking, or smaller footprints on memory. So generally speaking, you will get better performance because there's optimizations in the JVM, the ability to use things like native CPU instructions, new CPU instructions. So yes, even if you don't use the new versions, the new syntax, you will often get a performance improvement by using a newer version of Java. You will often also get better memory usage, particularly as things like compact strings came in. So that means that your string values use less memory, and a bunch of other smaller improvements, things that you don't have to use in your syntax as a developer, stuff that just happens under the covers, will do things like improve the memory usage. Now, this is interesting because this actually allows you to potentially save money, and that's interesting to the business. In Java 11, we had a whole bunch of garbage collection improvements. So now G1 is the default garbage collector, and there's a whole bunch of stuff around a parallel full GC for G1, and then some new experimental garbage collectors. Now, it might be interesting to ask the question, why do we need more than one garbage collector? But each of these garbage collectors has a different profile, has a different use case. So instead of you having to tweak all the different variables for the garbage collector to figure out a way to get it to be the most performant for you, maybe you just try one of these 2 or 3 different garbage collectors, and straight away one is just much better for you because it's better for your use case. So there are some new garbage collectors that are currently experimental. In Java 14, there are even more improvements to these new garbage collectors, and more improvements to G1, more improvements to ZGC. So in Java 14, garbage collection is also improving enormously. Now, with the performance improvements, the memory usage improvements, the garbage collection improvements, this will generally lead to lower cost running your application, probably, especially if you're running it in the cloud. Now, we don't have a lot of time to do tips for migration because really this is a topic for an entire another talk, but I do want to mention a little bit about tips for migration because I know there is some fear about moving off Java 8. You may have heard horror stories of Java 9, you may have heard horror stories about deprecation and things being removed in the module system and things like that. I don't want to go into those in too much detail, partly because I've already written about them in another article. I do want to give you some quick pointers which might help the majority of applications just to move forward straight away. So firstly, you could actually just try running it on an updated JDK straight away. I did this with a couple of open source applications. I just literally ran it in CI. I didn't make any changes to the code or anything like that. Just literally operated it against a modern version of the JDK, and it just ran just fine. So you might find it just works. If it doesn't, you want to first take a look at compiler warnings. There were a bunch of compiler warnings added in Java 8, for example, and earlier. These compiler warnings are there for a reason, and things like deprecation warnings, things like that. You want to look at warnings, you want to address them. If something is deprecated in the modern world of Java, it will probably go away at some point. So do take things like deprecation warnings very seriously. Update your dependencies. You should be doing this anyway because dependencies are a source of security issues. So you really should be updating the versions of the frameworks and the libraries that you're using. So you really want to update these to the most recent version of your dependencies. You may need to add new dependencies as well. There are certain areas of the system which have been removed from the core JDK, including JavaFX and including some of the Java EE APIs. So you may need to add a specific dependency on an external library where you didn't need one before. It's just another line in your build tool or your Maven or your Gradle or whatever, but you may need to do that. Speaking of which, you absolutely must update your build tool. You have to have a modern version of Maven or Gradle to run Java 11 or Java 14. Java 14 runs on Gradle 6.3. I know this because I was just recently struggling with it. So you do need to update to the most recent version of your build tool. It won't work. The modern versions of Java won't work on old versions of Maven and Gradle. And then finally, the next step is to actually compile against the updated JDK and start using the shiny features. This is not step 1 when you're trying to upgrade your version of Java. This is step at the end, step N. Now, as I mentioned, I have written a more in-depth article about how to upgrade. It says upgrading Java 8 to Java 12, but that's because it was written last year, and these versions of Java keep moving so fast. But yeah, it basically tells you about your two options to go to either Java 11 or Java, the latest version of Java, and gives you some steps on how you might want to do that. So, in summary, Java is changing, and it's changing fast. We're getting new releases every 6 months, and this is a big change for the Java world. Modern Java can help you. It does reduce boilerplate, which can help us in terms of the maintenance cost of code. It does improve performance. It can reduce the cost of running your application. There are two main upgrade options. You want to upgrade to the most recent LTS release, which in this case is currently Java 11, or to the most recent version of Java, which is currently Java 14. And if you upgrade to the most recent one, you need to keep upgrading every 6 months. Thanks very much for watching this video and for listening to me. I have got a list of all the resources here at this URL. So there's a link to, well, you can see all the slides. There's a link to another presentation of this video. There's another presentation which goes into way more depth about the licensing changes and so forth. And there's all the links that I mentioned in the slides are all available here. So thanks very much for watching.